Kids, Smath here, and I want to make a video for you today on a topic called dimensional analysis. And this is a topic that's really central to the study of science and chemistry and physics in particular, because it's also known as factor label method. And this is a mathematical skill that I think if you learn and master this early on, I think this is going to help you in for a lot of years to come as you study science. And even it's a good way of thinking about math problems. So, what does this really mean? We have a couple absolutes that I continue. I just want to make sure we're all clear. All numbers must have a unit. There will not be partial credit on this. All numbers must have a unit. No unit, no credit, period. It's essential. It's the heart of learning how to solve these kind of problems. And so what we're going to do is set up a bunch of conversion factors, and these conversion factors are going to be fractions that are equal to 1. And so we're going to give you some steps to use here. The steps are pretty simple. The first thing we want to do is identify our starting unit. Our starting quantity. And so this is going to be given in the problem. It's always going to have a number associated with it. So as you see, you know, how many seconds are in 2.54 days? 2.54 days is your starting quantity. So we're going to start out with that. Then we're going to write down the conversion factors. And we have to write those conversion factors in an order so the units between the starting quantity and the desired finishing, those units are going to cancel out. That's really what we're looking for with all of these. So, an idea of a conversion factor, i.e., a conversion factor would look like 60 seconds in 1 minute. That's equivalent to 1. 1 minute is 60 seconds. Those two things are equal. And so we have to arrange them so that the units cancel. The units have got to cancel. And if the units cancel, then it's just a matter of us using our calculator and multiplying across and dividing. And so that's our next step. So 1, 2, 3. We're going to multiply across the top, multiply across the bottom, and divide at the end. Okay, step by step by step. Okay, go all the way across top, all the way across the bottom, multiply, then divide at the very end, and then 4, we're going to check and make sure our units cancel. So the way we're going to teach this for starters, because I know we can calculate how many seconds are in a minute and we know how to get all the answers to that, but we're really trying to learn this strategy because next chapter we're going to be dealing with things that we don't know about seconds and minutes. It's going to be a much more complicated unit of study. So we're going to be working with what are called nonsense words. So these are going to be some conversion factors that we're going to use. These are going to sound silly, but they really help us understand the process. And these are green, so they are given. So don't worry about those. And let's start out with, again, they're nonsense. So 1 glim, I don't know what a glim is. It doesn't matter. That's going to be equal to 8 torps. Okay. Then we're going to have 1 sprox. A lot of the times these conversion factors will have a 1 in them. 1 sprox is 2.5 quans. I did not make these up, not by any means. Then we have 3 vinks is 5 torps. And 7 blinks equal 20 sprox. It's going to continue over here in the next column. 2.5 vinks is going to be equal to 11 flibs. And what else do I have? 6 flibs equal 13 zoops. Nine blinks is going to be 4 zoops. So these are just given conversion factors, no different than seconds, minutes, grams, kilograms, could be anything. Okay? Now we're going to go through a series of examples where we're using these conversion factors to get from glims to quans to torps to sprox, whatever the question may ask. The first 3 are going to be very straightforward. They're going to be single step problems. So in this case, problems select here of, let's see here, EX1. And let's convert 36 glims. That's my unit. And we want to convert that to torps. Okay, should be pretty doable. So we're going to have to move, get that out of there. Move him down there, actually. Okay, so now let's see what we've got. Let's start with our first step was identify my starting quantity. My starting quantity is really easy to find in these problems. It's 36 glims. What I need to do is say, do I have something that gets me from glims to torps? And my first one sure does. It's right off the bat. This should be pretty easy. So I want to put torps on the top. I'm going to put glims down below. And 1 glim, 8 torps. And I'm going to multiply that out, 36 times 8 divided by 1. That's going to give me 288 torps. Now, we've talked about how we're going to round and what we're going to do with that. There's only two digits in this number 36. So 288 really isn't my right answer. I can only have two digits there. So I have to have 290 is the better answer. So just to make sure, 290 is right, 288 is overrepresenting, and you're going to lose a point on that. And it's a silly point to lose because your answer can only have as many digits here, 2 and 9, as my answer here. Now, the other thing you could do that would save yourself as well is you could say 2.9 times 10 to the second torps. And that works just fine as well. It's a great answer. Put it into scientific notation. Do we have to? No, but it helps us with keeping up with how many digits we could have. Okay? There's a real easy problem. Every number has a unit. The work is organized. It's legible. A lot of you guys, we need to work on, hey, let's increase our legibility here. Let's make our work shine. Let's make it better than the best work it could possibly be. Let's see what we have for example number 2. Another one-step problem, keeping things pretty simple. And in this case, let's take 200 torps. So convert 200 torps. No, I'm not abbreviating. I'm not shortening. I'm using what was given. Okay, 200 torps, we're going to convert that to vinks. If these seem like they're very simplistic problems, they are. So let's start with what we're given. We're given 200 torps. Draw the line, draw the train track. This is how I'm showing you to do this. Use these dividers. Don't just put multiplies and dots and times and everything else. We're trying to learn a process of problem solving. Please follow how I'm trying to teach this. So I need something that's going to convert from torps to vinks, and I have one right here. And I've got two numbers in this case. My torps are given. So what I want is my torps to be on the bottom. That way my units will cancel. When my units are diagonal, doesn't matter which way. If my units are diagonal, they're going to cancel. And then I have 3 vinks. So what I'm going to do for this problem to solve it is 200 times 3, okay, divided by 5. And that's going to give me 120 vinks because 200 times 3 is 600. 600 divided by 5 is 120. And it's 120 vinks. My torps cancel with my torps. Just like in my first example, my glims canceled with my glims. And there's my answer. Okay? These are very straightforward one-step problems. Super simple. Let's look one more, just because examples can always come in threes. Here's example 3. Convert. Get 18 sprocks. Let's convert that to quans. So here we go, one step at a time. Start with your 18. 18 sprocks. Make your train tracks. Make the dividers. No, we're not doing times. We're not doing dots. make the dividers. We're looking for something that's going to take us from sprocks to quans. Let's go back up to our conversion factors. And if you look at the top of your conversion factors, we should have the very, where is it? It's the second one down right here. I've got sprocks and quans. One sprocks, 2.5 quans. 18 times 2.5 is 45. Quans. Pretty easy. These are one-step problems. They're not meant to be very hard. None of this is meant to be very hard. We're trying to set you up so that when we start doing with atoms and moles and mils and volume and things you're not familiar with, you're going to have a strategy that you can rely on that's really going to help you out. So let's do a couple of multi-step. And so these are going to require us a couple of conversion factors. We're just going to string them together. So for example, number 4, we're going to convert from, let's convert 25 vincs and we're going to convert that to zoops. And so our starting number is 25. That has 2 digits in it. My answer is going to have 2 digits in it. This is going to be challenging for some of you. It's going to bother you maybe. Okay, I'm going to make my line a little bit further here. Okay, and I have 2 conversions now. What I want to do is go from vincs to flibs, and we have a conversion factor for that, and that's 2.5 under 11. And so now my vincs have canceled. Now I got to go from flibs to zoops. And so my flibs are going down here and my zoops are going there. And I've got a conversion of that. So I have 6 flibs, 13 zoops. You're not memorizing any of those. Those conversion factors are being given. I'm just asking you to use them and show me that the flibs are being canceled. Multiply 25 times 11 times 13, multiply 2.5 times 6, and divide at the end. Okay, now my calculator is going to tell me this is 238 zoops. And we're caught in the same problem we were last time, where my answer that my calculator is giving me is 3 digits, but my problem is only giving me 2. So I've got to turn 238 into 2. And the best way to do that is with scientific notation, make it 2.4 times 10 to the second zoops. I don't know of another way to get an answer for this. All right. This 238 and only being able to represent 2 digits is a real problem for us. And I don't have control over that. You don't have control over that. But this is why we have scientific notation. All right. Now, we've done some pretty easy ones so far. Let's kick up the difficulty. Let's do a hard multi-step one so that you have a hard one in your notes. So in example number 5, we're going to convert 10 glims. and we're going to convert those into quans. So let's start with what we're given. We're being given 10 glims. I'm going to need a pretty long line for this one because I know this one's going to take a couple of steps, more than a couple. Okay. So 10 glims. I can go from glims to torps. Okay. I can go from torps to vinks. I can go from vinks to flibs. I'm going to fill in the numbers in a minute. I'm going to go from flibs to zoops. We just used that one in our last problem. Flibs to zoops. Now I'm going from zoops to blinks. Got to get a couple more in. I got to go from blinks to sprocks. And I've got to go. My last step is to go from sprocks to quans. Okay? Because before I even fill any numbers in, if I look at my units need to cancel glims, cancel glims, torps, cancel torps, vinks, cancel vinks. It all happens on the diagonal. Flibs, cancel flibs, zoops, cancel zoops, blinks, cancel blinks, sprocks, cancel sprocks, and the only unit that's left is the unit at the end, quans. Now let's put some numbers in here where I've got 8 torps in 1 glen. I have 3 vinks in 5 torps. I have 11 flibs in 2.5 vinks. I have 13 zoops and 6 flibs. I have 9 blinks in 4 zoops. I have 20 sprocks in 7 blinks, and there are 2.5 quans in 1 sprocks. That's the setup. Multiply it all the way across the top, multiply it all the way across the bottom, divide it at the end. This is going to give us the same problem we've had. The calculator is going to spit out 7354 quans. But my problem only had 2 digits in it. So I only get to represent 2. So this is going to be in scientific notation 7.4 times 10 to the third quans. That's the only answer we could possibly have. Okay. That's about as complicated as a problem as we're ever going to see on any of these. Okay. Let's watch out. There are some common mistakes that students make on these kind of problems. One, they don't get their units to line up diagonally. Okay. They have to be diagonal. They have to cancel. Problem number 2, they skip steps and they think they can just go from point A to point B in one. Don't try to skip steps. Write them all out, put all your units, And the other thing that students sometimes misconstrue is they get their conversion factors right side up or upside down. And the way to avoid that is if I have glims on the top here, I need to have glims on the bottom there. That's going to let them cancel out. Okay. Tips to help you score. Make sure you write a unit on every number, box in your final answer, and watch the number of digits that you can write. We can only write an answer that's as accurate as the number given in the problem that was given to us. So that's how you solve nonsense problems. I've got a worksheet coming up for you on this, and I hope this video helps you.